Now we shall see exercise 1.1 second problem. What is given? Write the set notation. Within the set notation you have -1 and 1 in set builder form. That means this is given in terms of roster form. We have to rewrite this in set builder form. What is roster form? For x is equal to -1 and +1. And said you have to convert, you have to find out the values of x. For a given x is equal to -1 and x is equal to +1. X is equal to, let this value as -1 and this value as +1. Therefore, x -1 equal to 0 and x +1 equal to 0, x -1 equal to 0. Therefore, you combine these two equations. X plus 1 into x minus 1 equal to 0. Therefore, x square minus 1 equal to 0. Because you have in the form a plus b into a minus b. For a, what is the formula for a plus b into a minus b? A plus b into a minus b is equal to a square minus b square. Therefore, x plus 1 into x minus 1 you have in this pattern. For this, because if you use the formula, in the place of a you have x, in the place of b you have 1. So by applying this formula, this becomes x square minus 1 equal to 0. Or you can also say that x square is equal to 1. Therefore, they are given in terms of set builder. We have a roster form. We have to convert this in set builder form. Therefore, set builder form. Set builder form. Set builder form. How do you write set builder form? Set for x is a real number because you have +1 x values you have +1 and -1. Therefore, you cannot write it is a natural number because in natural number you have only set of positive numbers 1, 2, 3, etc. Because here we have -1. Therefore, you write like this: x belongs to real number. X is a real number such that x square equal to 1. Therefore, given in roster form, you have converted into set builder form. Next, we shall do the third problem. What is the third problem? I have written that said. State the following sets. We have to find whether the given 5 sets are finite or infinite. Finite or infinite. State the following sets are finite or infinite. So first one. Third one. First problem. What is first one? Set of all x is a natural number. N means natural number. Such that x is an even prime number. You know what are prime numbers? Even prime number. Even prime number. First of all, we shall see what are prime numbers. Prime numbers. 2, 3, 5, 7, 11, 13, etc. etc. You have so many prime numbers. But we are considering in first division 1, we are considering only x is an even prime number. What is even prime number? Only one you have. Only one prime number you have, even prime number, that is 2. Therefore, 2. Even prime number you have only 2. That means you have, this is finite set or infinite set. You have only one element. That means countable. If we have countable number of elements, it is called finite set. If we have uncountable number of values, means it is called infinite set. Here we have countable number. That means only one set. This is also one name we can call this a singleton set. If we have only one element in a set, it is called singleton set. Singleton set. All singleton sets are finite sets, singleton set, because you have only one value. Therefore, this is called finite or infinite. Finite set, because you can countable. You have countable number of values. What is called finite set. Next. Second division. What is second division? X is a natural number. X is an odd prime number. First, second division. X is a natural number such that X is an odd prime number. Odd prime number. Odd prime number. Just now we have seen what are prime numbers. Prime numbers means 2, 3, 5, 7, 11, 13, etc. Goes on. You have infinite set. Set of prime numbers is a finite set or infinite set. Infinite. Why mean? You have uncountable values. So it is called infinite set. But here even x is an odd prime number. Odd prime number is 3, 5, 7, 11, 13. Only 2 is an even prime number. Therefore, we have to neglect to cut 2. Because 2 is an even prime number. Because here in the set they are given x must be an odd prime number. For these numbers only we have to consider. Therefore, you can see that this is finite or infinite because you have uncountable values. Therefore, it is called infinite set. Infinite set. Now go to the third one. X must be an integer. X belongs to Z. Z means integers. And X is even and less than 10. X is even and less than 10. Less than 10. What are integers? Integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, is etc. It's called integers. Integers. You have positive values as well as negative values. Integers means you have even 0 is also included. Positive values plus 1, plus 2, plus 3, etc. And also you have minus 1, minus 2, minus 3, etc. Now come to the problem. X must be an even number. Even number means odd numbers and all we have to cut. 0, plus 2, plus 2 and minus 2, and also you must cut not all numbers, those numbers must be less than 10. Consider all the integers and also they must be less than 10. Therefore, required set is equal to, for less than 10 means 8, 6, I'll consider 0 is also there, 0, even means 2, 4, 6, 8, less than 8. Last number is 8. And here also you have negative numbers also there. For minus 2, minus 4, minus 6, etc. This side you have etc. Because it must be less than 10. Even minus 6 is also less than 10. Minus 8 is also less than 10. Minus 10 is also less than 10. You have this side etc. Therefore, it's a finite set or infinite set. It's called infinite set because you have uncountable values. Infinite set. So first you must know what are integers. Integers means positive values also you have, negative values is also you have, 0 is also you have. But in the given set, you have to consider all integers and also two more conditions are given. There must be even number as well as there must be less than 10. For the even numbers means 0, 2, 4, 6, 8. But a 10 I have not considered because it must be less than 10, 8. For this side it will go on 0, minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, etc. Therefore you have uncountable values. Therefore given set is an infinite set. Now fourth division. Third one, fourth division. X belongs to R. R means real numbers. Such that X is a rational number. X is a rational number. X is a rational number. What are rational numbers? Any number of the form rational number. Rational number. Any number of the form P by Q. Any number of the form P by Q is called rational number. So 1 by 2 is also a rational number. 2 is also a rational number because 2 can be written as 2 by 1. And 3 is also a rational number because 3 can be written as 3 by 1. And 4 by 3 is also a rational number. For any number of the form P by Q is called a rational number. So how many rational numbers you have? You have infinite set. Therefore, this is an infinite number of values you have. X is a real number is a bigger number system. And after that only you have complex numbers. You will be briefly going to study complex number in next year. For real numbers is a bigger number system. You have all numbers, natural numbers, whole numbers, integers, everything, rational numbers, irrational numbers, everything consists of real numbers. For x belongs to R, x is a rational number. Means therefore given set is a infinite set because you have uncountable values. For infinite set. Infinite set. Next, fifth division. Set of all x is a natural number such that x is a rational number. X is a rational number. X is a rational number. What are natural numbers? 1, 2, 3, 4, 5, 6, etc. This is natural number. Natural numbers. And you have to consider all the values. That the value also, x must be consider x, it must be a natural number as well as it is a rational number. For rational number means any number of the form p by 2. For this also is a rational number because 1 can be written as 1 by 1. Or any number of the form p by q is a rational number. For 2 it can be also written as 2 by 1. 3 can also be written as 3 by 1. 4 also can be 4 by 1. Therefore any number of the form is called rational number. Therefore this is an infinite set. Infinite set. Infinite set. Rational number means any number of the form p by q. For 1 is also a rational. We are considering only natural numbers. 1 is also a natural number as well as you can call it as rational number. Why means 1 can be written as 1 by 1. 2 is a natural number as well as is a rational number. Therefore, why rational number means 2 can be written as 2 by 1. 3 is a natural number and also a rational number because 3 can be written as 3 by 1. Therefore, you have uncountable values. Therefore, given set is an infinite set. Next, fourth one. If n of P of A is equal to N of P of A is equal to 1024. 1024. And N of A union B. N of A union B is equal to 15. Is equal to 15. And N of P of B. N of P of B. N of P of B is equal to 32. 32. 32. Find N of A intersection B. A intersection B. See, given N of P of A, value given by N of P of A. This value is given as 1024. We know the formula. N of P of A is N of P of A is equal to 2 power n. This is formula. Number of elements in the power set A is equal to 2 power n. Therefore, 2 power n is equal to 1024. 2 power n is equal to 1024. Therefore, this you can write as in terms of 2 power n is equal to 2 power 10. Therefore, n equal to 10. Therefore, number of elements, n means number of elements in the set A. That is, n of A is equal to 10. That is, n is equal to 10 means number of elements in the set A is equal to that you can usually denote as n of A equal to 10. Next, n of P of B is 32. N of given n of P of B equal to 32. By formula, 2 power n is equal to 32. 2 power n is equal to 32. Therefore, 2 power n is equal to 2 power 5. Therefore, n equal to 5. Compare. Base is same. Base are equal. Equate the powers. Therefore, n equal to 5. Number of elements in the set B equal to 5. N means number of elements. In which set? Number of elements in the set B equal to 5. Therefore, n of B is equal to 5. What you have to find out? Find n of A intersection B. How do you find n of A intersection B? We have one formula. N of A union B is equal to n of A plus n of B minus n of A intersection B. For n of A union B is equal to n of A plus n of B minus n of A intersection B. N of A in B given n of A in B value is 15. N of A in is 15. N of A we have found out. N of A is equal to 10. And n of B is equal to 5 plus 5 minus n of A intersection B. What value you have to find out? N of A intersection B. Therefore, 15 equal to 15 minus n of A intersection B. Therefore, 15, they take this 15 to the power 15 minus 15 equal to minus n of A intersection B. Therefore, 0 equal to n of A intersection B.